Hi everyone, welcome back to Math Together Canada. In this video, Kaylin will be working through questions 5 to 12 of the 2024 AMC 10B, where the difficulty starts to ramp up a tiny bit. Follow along and see how she approaches each problem.
So for question 5, the problem says, in the following expression, Melanie changed some of the plus signs to minus signs. So 1 plus 3 plus 5 plus 7 plus ... plus 97 plus 99. When the new expression was evaluated, it was negative. What is the least number of plus signs that Melanie could have changed to minus signs? So first we can evaluate this sum. So these are the first 50 odd numbers. So that means that their sum is going to be 50 squared, which is 2500. So we want the new expression to be negative. So basically we want to find numbers. So let's say that the numbers in this box are the numbers following a plus sign, and the numbers in this box are the rest. So we want this number to be negative, and we also want to change the least number of signs. So that means that each box should be as close to 2500 divided by 2, which is 1250, as possible. So if we want to change the least number of plus signs, then we want to change all the signs in this part of the sum. So the last, the least amount of numbers so that it's negative, and the numbers are all in the last half, going from greatest to least. So basically we want to find a number n so that the number, this sum, which is equal to n squared, is less than 1250. And we want to find the greatest possible n such that this is true. So we see that 1250 is between 35 squared and 36 squared, which are 1225 and 1296 respectively. So that means that we want n to be 35. So this means that 2n minus 1 is equal to 70 minus 1, which is 69. So then basically we had 50 numbers to begin with, and now we're changing, we're keeping 35 the same, so that means that we're changing 15 signs. So this is B, which is 15. Okay. Next question. Question 6. A rectangle has integer side lengths and an area of 2024. What is the least possible perimeter of the rectangle? So I guess we can first prime factorize 2024. So this is equal to 2 to the power of 3 times a 250, so times 11 times 23. Also, just as another note, it's a good idea to remember the prime factorization of the current year. It is currently 2025, so I don't remember 2024. But yeah, so for this year's contest, just try to remember that 2025 is 45 squared, and 45 is 3 squared times 5. Okay, back to the problem. This is the prime factorization of 2024, and we want the least possible perimeter of the rectangle. So we want the width and the length to be as close as possible to each other. So over here, the two sort of factors that are the closest to each other are 44 and 46. And by two factors, I'm referring to two factors that multiply to 2024. So because these two are the closest to each other, this is the ideal or the best width and length for the dimensions of the rectangle so that we are minimizing the perimeter. So over here, the perimeter is going to be equal to 44 plus 46, which is 90 times 2. So that is B, 180. Okay. Problem 7. What is the remainder when this is divided by 19? 7 to the 2024, we can factor this. So we can factor 7 to the 2024 out. So this is 1 plus 7 squared, which is equal to 7 to the 2024 times 1 plus 7 plus 49. And this is 57, which is equal to 3 times 19. So basically, this tells us that this sum over here is a multiple of 19 because it's a multiple of 57. So that means that the remainder when it's divided by 19 is A, which is 0. Okay. Next question. Problem 8. Let n be the product of all the positive integer divisors of 42. What is the units digit of n? So we can write out 42 as 2 times 3 times 7. So this means that there are 8 factors. And if you couldn't tell that, either you can just count them out. There's only 8, so it's not that hard to count. Or you see that each factor here has, each prime factor has a power of 1. So we can add a 1 to each of the ones and multiply them together. So it becomes 1 plus 1 times 1 plus 1 times 1 plus 1, which is 2 times 2 times 2, which is 8 factors. So no matter how you do it, there's going to be 8 factors. And we can pair them up so that each pair has a product of 42. So we can just take 2 to the a times 3 to the b times 7 to the c, and then take 2 to the 1 minus a times 3 to the 1 minus b times 7 to the 1 minus c. And we see that 42 is not a perfect square, so that means that no factors are going to be in 2 pairs. So there are 8 factors, so there are 4 pairs that multiply to 42, so that means that n is equal to 42 to the power of 4. So the unit digit of n is going to be equal to 6, which is also the unit digit of 2 to the 4, which is 16. Okay. Next question, question 9. So real numbers a, b, and c have arithmetic mean 0. The arithmetic mean of a squared, b squared, and c squared is 10. What is the arithmetic mean of ab, ac, and bc? So arithmetic mean basically just means average. So a plus b plus c over 3 is equal to 0. So a plus b plus c is equal to 0. And then a squared plus b squared plus c squared over 3 is equal to 10. So a squared plus b squared plus c squared is equal to 30. Right? Oh, that's a 0. Okay. So we can square a plus b plus c. So a plus b plus c squared is equal to a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. And this is equal to 0. You should try to memorize this for a contest just to make it quicker to expand. But yeah. So we know that this part is 30, so this part is negative 30. So 2ab plus 2bc plus 2ac is negative 30. So ab plus bc plus ac over 3 is negative 30 over 6, which is negative 5. This is a 6. Okay, so for problem 9, the answer is the arithmetic mean of AB, AC, and BC is negative 5. Okay, question 10. Quadrilateral ABCD is a parallelogram and E is the midpoint of the side AD. Let F be the intersection of lines EB and AC. What is the ratio of the area of quadrilateral CDEF to the area of CFB? Okay, so I drew out a diagram for this question, so it's over here. And the two shaded areas, so CFED and FBC, are what we're looking for. So I also put a variable b, which signifies the area of triangle AFE, and we're going to try to write each of the region's areas in terms of b. So first we see that E is the midpoint of AD. So that means that BC is equal to 2 times AE, sorry. Right, so we know that triangle BCF is similar to triangle EAF through angle-angle similarity because AE is parallel to BC. And so because AE is half of BC, that means that the area of BFC is going to be 4 times the area of AFE, which is 2 squared. And we know that BC is equal to 2AE, so BC over AE, which is also equal to BF over FE, is equal to 2. So that means that the area of ABF is going to be 2 times the area of AFE, so this is 2b. And finally, we know that, so the area of ABE is a quarter of the area of ABCD. And this is because the area of ABE is half the area of ABD because AD is twice AE, and the area of ABD is half the area of ABCD because BD is a diagonal. So that means that the area of ABCD is 4 times 3b, which is 12b. So now we have that the entire area is 12b, and we have b, 2b, and 4b right now. So the last area is 5b. So now we're looking for the ratio of CDEF to CFB, which is 5b to 4b. So the answer is A, 5 to 4. Moving on to question 11. In the figure below, WXYZ is a rectangle with WX is equal to 4 and WZ is equal to 8. Point M lies on XY, point A lies on YZ, and angle WMA is a right angle. The areas of triangles WXM and triangle WAZ are equal. What is the area of triangle WMA? So if we zoom in, first we can label what we know. So this is 4, 8. So assume that AZ is equal to some variable A. Because the areas of WZA and WXM are equal, XM is equal to 2M. So now MY is 8 minus 2A and AY is 4 minus A. So then AM is equal to 4 minus A times root 5 by the Pythagorean theorem. So consider triangle WMA. WM squared plus MA squared is equal to WA squared. So 16 plus 4A squared plus 5 times 4 minus A squared, which is 16 minus AA plus A squared, is equal to 64 plus A squared. So we can move things around, or I guess we can first expand the left-hand side. So 96 minus 40a plus 9a squared is equal to 64 plus a squared. So 8a squared minus 40a plus 32 is equal to 0. So a squared minus 5a plus 4 is equal to 0. So either a is 4 or a is 1. But we see that obviously a cannot be 4 because then that would mean that ay would be 0 and ay is not 0. So that means that a is equal to 1. So that means that the area of WMA is equal to the area of WZYX minus the 3 other triangles, which is 32 minus 4 minus 4, and then minus, we see that this area is 3 times 6 divided by 2, which is 9. So that means that the area of triangle WMA is 15, which is C. Okay, so for question 12, a group of 100 students from different countries meet at a mathematics competition. Each student speaks the same number of languages, and for every pair of students A and B, student A speaks some language that student B does not speak, and student B speaks some language that student A does not speak. What is the least total number of languages spoken by all the students? Okay, so we can say that the total number of languages is equal to A, for example, and each student speaks B languages. So there are A choose B ways to assign B languages out of the A to all the 100 students. So we want this to be greater than 100. And we're looking to minimize A. So we see that if A is less than 8, then the maximum number of combinations would be 70, which is 8 choose 4. So that is not possible. But when A is equal to 9, then 9 choose 4 or 9 choose 5 are both equal to 126, which are greater than 100. So that means that when A is 9 and B is 4, so there are 9 total languages and every student speaks 4 languages, all the conditions that we are given are satisfied. So that means that the least possible number of total languages is 9. So this is A.
Great job making it through questions 5 to 12. Thanks for watching, and don't miss part 3, where the problems really start to ramp up in difficulty. Make sure to subscribe so you don't miss when we upload, and we'll see you there.